So in the last video I showed a quick demo of it e-stopping, and it does actually detect the stall and stop the machine. So it's pretty good, but I know what you're thinking. Could it be improved? Okay, in this video we'll upgrade this little sensor unit from the Spiro board type to a proper PCB, and then also 3D printed this little template to make it easier to assemble. And then you might remember this board I modified in the last video. We've got a nice fresh board here with all those modifications incorporated. We also need to go and change the code to make that a little bit more efficient and optimized. And while I was there, I thought I'd add this handy undo feature just in case you make a mistake. Very nice. So I thought I'd start with a sensor that goes inside the spindle and detects the RPM. And the first components to go in were the resistors, just so I could get those in and get those off to one side to make sure I had enough room for the connector. Connector was in next, and that's a JST PH, 2mm spacing, and that's a 3-pin obviously. The transmitter or emitter is there, short leg is negative, same on the receiver, which is the blue one. We just got to be careful when we put them on the board. So the transmitter, the flat end there is negative and it's positive on there, and then the receiver is backwards. So the flat side, I don't know if you can see it in the little symbol there, is actually the positives, it's kind of reversed. Right, so we need to make sure we get that right. And then the other thing is those are coming out the bottom here, and then they go through like a 90-degree bend and then off into the housing. So we'll set all that up, make sure we get these the right around, and then solder those in place. Okay, now we've got that far. That's roughly centered front to back to give me some adjustment. And now I've got to get those into there. Bend the legs over. And we'll solder those in place. Okay, looks like our little fixture did the job. Right, let's test this out and make sure it actually works. Okay, this is several hours later, and I've been messing about with the board and I couldn't get any readings out of it at all. So I started swapping components in and out, and then I think I ended up damaging some of the tracks. I lost some continuity, and that was on this board here. Tried to get all the components off, but yeah, struggled with that and decided, okay, let's just leave that one. Started testing some of the photodiodes and so on, and the original ones I'd bought, I think, were these ones, and I don't know if they're faulty or I just couldn't get them to work at all. So I went back to an older style that I'd used previously. You might be able to see coming like a little 2-piece send and receive head, and I think last time I took them out of there and used those, and those are working as expected, so I don't know what the other ones were doing. So anyway, I've been building this one back up in stages. I've tested the resistance and tested each of the tracks and been building it up, and I've got my little that's the infrared LED in there, and just to prove, I've got power on there and I've got scope hooked up as well, just to prove that is working. I can just put an LED across there as well. I've got power on, yeah. Oh, and it's not working. What have I done? Oh, it's been one of those days. Alright, tell you what, maybe it's not enough current to run both. Alright, let's just drop that in there. Alright, okay. We're definitely getting power, and yeah, we're drawing a small amount of current upon the power supply there. Right. So, circuit works up to there, and we know, I just drop that in. Obviously we can't see infrared, so it's difficult to tell if that's working, but there is something we can do using the receiver just to check. Okay, so we assume we're getting some light off there. I don't know if the camera can pick that up. No, maybe not bright enough. Assume that's giving out some infrared light, and we've got an infrared receiver here. Now, because it's out of that little head unit, it's hard to tell which one's positive and negative. So I've got it in diode mode on here, and we'll just randomly try across, say, those two legs, bring it closer, and we should see the value drop to 1. No. Okay, try the other way around. I guess this is the way it wants to work. Oh, that might mean the LED's not, because I haven't soldered it in, because I just want to make sure everything works first. Let's try that. Right, try it again. Try the other way around. Nope. Oh, hang on. There we go. Okay, so as I bring it closer, we're getting a reading in diode mode on there. So that's the positive, so it's flowing that way. So that needs to go through there. So what I'll do then is just crop that lead a little bit shorter, so I know that is the negative. So in theory, it should go that way around. So I'm going to temporarily put them in there, not solder them, but just put them in there and test the circuit works on the scope. Then I know it's all working, and I'll get them set back up in the jig, solder them in the right position, and then we can go from there. Or as a note to my future self, in case I do one of these again, I realised I just had the LEDs on the wrong side, so they go in on the underside, and the long legs, the positive ones, are in the outside, and the two short legs are in the centre, which is actually same as I got it marked on the board. You see the positives are on the outside there. Right, let's take it out of here and put it in the actual housing, which is this one. Should hopefully slide in there and line up. Okay, we'll just put it there for now. And we've got something like this, the solder sucker. That might be reflective enough. So I've got this hooked up to the scope, and it's currently on 0 volts. So if we put that in there, okay, it's jumped up to 3 volts. 0, 3. All right. It's finally working. Okay, I think it's about time we started populating the main PCB board. So the board's here, and the main differences between this version and the previous one is I've spaced out the test points, so it's a little bit easier to get the probes in without them shorting out. The second difference is I've spaced these out at 3.5mm to match the 3.5mm terminal blocks that I've got. The previous ones were spaced at 3.8, which is an imperial measurement. And obviously these are a little bit of a tight fit, but now they fit nicely in there. And then the third change is most of the board now runs on 3.3 volts. So you might remember last time I broke some of the tracks, remade some of the connections to run one of the sensors off 3.3. That's all now part of this design. So I think the only thing left to do is to get going on it, and then we can test it. Okay, we've got all the resistors on, so let's solder those on first. Okay, all the soldering complete. I've just got that in as a placeholder. I think it's actually damaged, but it's just a good way to space out those pins when I put those headers on there. So we'll sort that out for the actual one that's got the code on in a minute, but the rest of it I think it's ready to go. So take it out of here and we'll get it over to the electronic control cabinet, hook everything up and see if it works. Okay, the old board's out, got the new one in, got the wiring in, the microprocessor in. There's one more job we needed to do, and that is come over to the machine and solder on that little JST PH connector onto there. Okay, and then while I was putting the little spindle together, the housing, I've just noticed that if you have the circuit board all the way in, it actually, that connector there is actually inside where the main body of the spindle needs to be. That's okay because it will definitely work out here, but it does mean those three little wires there are very close to the back of it. So I think for now I have to put a little bit of Kaftan tape on that and yeah, make sure I'm running it all the way out back there. But I think I'm probably going to redesign this because getting the 13mm spanner in to lock off the spindle is a bit tight here. Could do with about another millimetre. I think there is space now with those little smaller 3mm infrared LEDs. I can go up a bit, but then it does mean I've got no more seal path here, so I'm going to have to redesign all that, and then obviously the lid won't fit, so I'll have to redesign that. So yeah, more iteration. Anyway, for now I'll put some tape on there, get this wired up and see if it works. But I was having a lot of problems reading the RPM. A lot of times it wasn't working at all, or it'd be very jumpy and intermittent, and it kept going to e-stop, so there was clearly something wrong with it. So this is one of the earlier little sensors. That was my little Vero board version. So obviously I've made that up into the new unit now. This is my second attempt at this, or actually third attempt, with some longer legs on the LEDs. We'll get into why in a minute. And I was iterating the housing and looking at different designs, wondering why it wasn't quite working with the new read head, if you like. And basically I think I just got lucky in the position of the infrared send and receive, just exactly where they came out in the channels. It was making the right beam pattern and it was detecting really nicely. But the new one obviously looks a lot nicer, but wasn't quite working. So yeah, I was playing around with the channel design there. Also I needed to move this surface up a bit, about 1mm, so I could get the 13mm spanner in to lock off the spindle when you're changing the bits in the collet, because it's got two flats on there and I couldn't quite get the spanner in. So when I moved that up, some of this geometry in here changed. I tried to recover it as best I could, but clearly it was too much of a change. So I've been tweaking the design, trying to get it to work. Yeah, and I was really struggling with it, but now I've got this final one here and I've ended up putting the holes, oh come on, the holes very close to each other, whereas on some of the earlier designs they were quite far apart. Oh, it's really hard to see, isn't it? Anyway, you might be able to see there. These are a lot closer together anyway. And some of the changes also made this an awful lot longer. So you can see that's a lot longer now, to enable me to basically slide this back, because one of the other problems I was having is this little sensor, or the plug here for the JST, it was really close when you put that in to where the spindle ends up being. So I'll just show you on the new housing where that ends up being. Now it's okay on this one, but imagine if to get a good signal you had to have it there. You can see how that is actually fouling where the spindle needs to go. So I was having to push that a long way back, put some tape on it to stop it shorting, and it was ending up, oh, that's come off. Alright, it was ending up being a long way out, and then these didn't work. Yeah, so long story short is I've got new design. It's got different spacing and different flaring to try and get the beam pattern optimal. These channels are a little bit better, the way it goes in here is better. This is longer, and I've ended up I need to put some Kaftan tape on there, but it's somewhere, I haven't found it yet, but that'll do for now. Yeah, I've ended up doing this, I think the second or third time, with some longer sensors on it, so I can position the board a bit further back. So the spindle still goes in, and I end up with those in the optimum position, which turns out to be just right at the edge there. And the beam form's okay, and I've just tried it and it reliably works. Right, so that's about quite a lot of hours of work on and off. So let's put this together, set it up, and check it still works in the spindle. Right, so I've got the sensor installed. I haven't put the back on because I haven't put the heatset inserts in, because I think I want to iterate that design a little bit further, make some more changes. So for now we'll run it like that. It will still work. Alright, just to show you it's working, I'll come out of there and turn off the reset. Okay. So it's tracking nicely. So there's a little bit of load on there. Now, the way I've got this load meter configured is, let's just stop that a minute. Yeah, so whatever percentage of follow error you say, so at the moment I've got it set for 20%, so that means if this speed falls below the demand by 20% or more, it'll trigger the e-stop, and then that is expanded out to this full range here of whatever, is that 9? So that represents 20% follow error. So if I change that to 50%, then that would represent a 50% error. So it scales it. So in other words, the number of bars shows you how close you are to tripping out the e-stop. So at 20% it's going to be pretty sensitive, and you'll see as I run it, it will jump around a little bit, because obviously any slight change is magnified at 20%. But we're okay, it's not tripping out, so let's get it running pretty low. You probably noticed a minute ago I got my glove on, so let's do a check and see how sensitive it is. So I've also changed the code. I've gotten rid of a lot of the like bits of code that I didn't need, that was commented out, just tidied it up, made a few minor changes, improved the way the sensitivity and detection works. So I think what you'll see now is it's pretty sensitive. So we'll go in again and try and install the spindle. Oh, I'm just going to grab it like that and just slow it down a bit, and you'll see what happens when I do that, and then we'll go for a full stop. Okay, here we go. Lightly grab it, and you can see it's jumping a little bit. Oh, there we go. So it's much more sensitive now. And there it has stopped. So I think that went 700, didn't it? So it dropped below. So it doesn't take much, which should mean it will stop a lot quicker than it did before. I think last time it was really pretty slow. Right, see if we can go a bit faster and still make it stop. Okay, again, just grabbing it. Yeah, that's not going to take much. It's gone again. I'd almost not really fully brought it to a halt, and it's stopped. So that is on a hair trigger. So if we go into the software, I think the menu is this one. Oh, it's sample time, so we can go past that. I could actually reduce that, because that'd be even more sensitive. But the lower you make that, the less accurate the calculation for what RPM it's calculating. So I'll probably leave that alone for now. It's a bit of a trade-off. Follower, yeah. So 20%. So if the speed drops below the demand speed by 20% or more, it will instantly stop. So the way I've got that configured is a lot more sensitive. We're not probably using that anymore. That's just if you want to scale the RPM reading just to make it absolutely match. You could optionally scale the RPM from the VFD, but it looks pretty good. And these thresholds are really for the deceleration and acceleration. They're just for the they'll just come out the menu. They're just when it's telling you the status there, nothing more than that. So whether it's triggered a threshold, say okay, yeah, it's not just fluctuating around, it's genuinely accelerating or decelerating. Yeah, a few changes behind the scenes in the code, but basically ready to try out. Right, so we've got ourselves set up. You can see the previous cut just there. We're indexed across. We're at 1mm depth of cut, and we're going to feed it at 400mm per minute. And let's see if it stops quicker than last time. So here we go. Start spindle. Right, 3, 2, 1. Well, it worked. It's a bit nerve-wracking, but it worked. It's gone straight to E-stop. We've stopped there. Somehow I need to work out a way to time how long it is, because there's a spool down time and so on. How long did it actually take to react? But actually, just by comparing, I don't know if that's any measure, you see how far it went before. This has obviously stopped a lot quicker, although maybe it gummed up quicker, I don't know, because it's the same cutter. Maybe it's getting a bit blunt. But point is, it stopped really quickly. It didn't break it. It didn't seem to kind of carry on and try to bend everything. It just stopped. So looks like it works. Yeah, let's try that again. And I don't know, should we try a different feed rate? Something like that. Let's change some of the parameters and see if it works again. Let's try it again. This time we'll be at 600 millimeters per minute. So it was 400 last time, 600 this time. Still 10,000 RPM. Let's get ourselves set up and try it again. Well, I could show you the machine, but it's e-stopped again. So that's caught it. Alright, what else can we try? Let's come out. Oh, of course we've got to reset it. Reset. Alright, this time 800 millimeters per minute. Still the same 10,000 RPM. Alright, let's give that a go. Oh. Alright, so I don't know if you can see that, but it looks like it's slightly bending. Like coming in at that speed, it still carried on a little bit further. I guess we can tell that if I try to turn it. Yeah, it's jammed. Now, it didn't break the bit, but it's clearly under a lot of strain. So there will be a limit to the system. I guess sometimes if you're going really quick, it might not stop in time. Or the cutter's getting really blunt. Let's just back it out very slowly and maybe we'll see. Yeah, so definitely e-stopped. So let's clear the fault. Reset that. And we'll just come out really slowly. Just see if we can see it kind of straightening up. Jog it out ever so slightly. No, it wasn't much. Yeah. Alright, looking pretty good. And we can also see on there, yeah, it's starting to gum up a bit. Which it might have been like that with the last cut, I don't know. But point is, it's working. Alright, so it's finally working. There was a lot of tuning towards the end in terms of the housing and getting the infrared beam to reflect and the optics to work okay. And there's a bit of tuning in the code, but it does actually work. Okay, so in the last video I said I'd upload all the Gerber files for the 3 boards. This one, the display and the sensor unit, and all the 3D files for the housing, display, the buttons and so on, and the little sensor disc. I think because I want to iterate this a little bit further, I've got some ideas now. I know what the optics needs to look like in there, how I can make that a little bit better and try and make this just a bit more robust. So I'll probably hold fire on that, but it'd be good to know in the comments down below if anyone's interested in making one of these yourselves, just so I can prepare myself and start doing the research as to the best way to share that information. I'm not looking to make any money. I'm happy to share all the files, but you know, if you get to that point, you will have to go and order these, order all the components and build the bits yourself. So I'll just show you how I did it basically, and feel free to take it, modify it and run with it as you see fit. But for now I think I'm going to iterate this design a little bit more, get it more robust, and once I'm happy with that, probably come back with a follow-up video. I hope you enjoyed that. All that remains to be said is thank you very much for watching, and